aiming the telescope, capturing light that began its journey 12 billion years ago. A few weeks later, near Princeton, New Jersey, Raja Guhathakurta is on his way to Tyson's laboratory. There they will analyze the data they gathered in Chile.
Tony is great fun to work with. Always excited about the projects he's doing, and he does generate a lot of excitement, and he does do interesting science.
Bell Laboratories at Murray Hill is one of the few commercial institutions to employ astronomers.
The computer set up there is ideally suited to this kind of reduction procedure, so it's most convenient to try to transport ourselves there instead of trying to transport all the software and equipment to another place. What we'll be doing is essentially reducing some of the data that we collected on this last observing run in Chile.
It should be returned to the tape archives. This is the final production image in color. These fuzzy yellow things and fuzzy red things, those are the galaxies that are in the cluster in the foreground. And see all these blue guys? Those are all distant galaxies, way, way behind the cluster. Many times further behind the cluster. And there are visible by eye many examples in these blue galaxies where they're aligned along circles centered on the center of the cluster. So these galaxies have been stretched. Their images have been stretched by the gravitational lens effect of the cluster. All the mass in the cluster causes these galaxies to appear at a different place on the sky than they would have otherwise. And as a result, their images have also been distorted systematically into these segments of circles around the center. And what Raja and I are going to do now is to start up some software which will analyze this final production image and will create a picture of the dark matter in the cluster.
Using a computer, Tyson creates a simulation of the gravitational effect of dark matter. We simulate the universe and then compare the results with what we find through the telescope. And it'll tell us if the simulation is wrong or right. When we get a good match, then we move around in parameter space to see how robust that match is. And that tells us quite a lot about what's really out there. Using this technique, Tyson estimates that 90% of the universe is in some unknown and invisible form. Dark matter lies not just in the distant universe that Tyson explores, it permeates the universe around us. All that we see is only the tip of a greater universe submerged in darkness. Dobson's stay at Crater Lake is over. It's time to move on. He carries his observatory in the back of his van.
The reason I got into this telescope-making world is because I wanted to help make it possible for people to see this world. And that's why we made these user-friendly telescopes. They're not designed to entertain photographic plates. They're for entertaining soft, warm eyes. Because seeing things in photographs is a very different thing from seeing them with your eyes through a telescope.
Dobson travels to parks and small towns.
He stops wherever people gather, giving his talks and holding his star parties, preaching the joys of astronomy.
You see, at all these places you go, there are so many people who are terribly interested in these things. And then you have to understand that the population of this earth is several billion, and all those eyes are waiting to see, all those ears are waiting to hear, all those minds are eager to understand. And somebody's got this job to do.
In the span of Dobson's life, astronomy has dramatically changed our view of the universe. Not long ago, we knew of only one galaxy, our own, the Milky Way.
See, when I was a kid, the universe didn't look like this at all. We only knew that we had one galaxy, our own galaxy. Nobody talked about galaxies in those days. They were called spiral nebula, the great spiral nebula, Andromeda, all that kind of stuff. All that's changed, and when Einstein came up with his gravitational theory, that's really when cosmology got going. And also because at the time we found out that there are galaxies outside of our own, and we wondered how far it goes. And so really the scientists took this broad view in the early part of this century, and that's running wild now.
At home in San Francisco, Dobson gives classes in telescope making at a nearby museum.
The class at the Academy of Sciences, they have a big enough mailing list so that they can get enough people together to run a class, and the class runs for 8 weeks.
Dobson is well known among amateur astronomers. The Dobsonian telescope design is world famous.
The farther away your eyes...
The instruments are hardly high-tech, but they're easy to build and a joy to use.
Rough grinding is a caveman's job. That's what we do this week. Rough grinding is a caveman's job. Eat well, sleep well, and work like hell. But there's nothing about it that we don't know how to do, and there's no boo-boo that you can do in this class which will be followed by a life of sorrow. The worst state you can possibly end up in is not having a telescope, and that's where you are now. I want them to see the universe. As I said before, I want them to see the universe, because if they don't see what the universe looks like, they won't wonder about it. And if they don't wonder about it, they're dead. What's the use of somebody that doesn't wonder? It's the hallmark of our species that we're continually wondering what's going on. But the specialty of these things is that they move easily. They go wherever you push them, and they stay wherever you leave them. But they don't track things across the sky. They're not good for photography, no. If you want to do photography, well, in the first place, you've got a disease. Because all the pictures have been taken by Lick Observatory, and all you have to do is go and buy them. You can't buy film for the price you can get the pictures. But nowadays what they do is to make this kind of a mount anyway, even if they do want to do photography, and then they put this on a Ponce mount. Now, Ponce is a Frenchman, and he writes to me, and he apologizes from France, and he apologizes for redesigning the Dobsonian. Anyway, he thinks that's real funny. And what we're going to do is to...
When I joined the monastery, I was working in the atom bomb project of the Second World War. I was working for the University of California, the radiation lab. And in the monastery, I became keenly tied up in these cosmological problems, if you like to think. So I wanted to see what the universe looked like, and so I helped somebody make a telescope, and then through that telescope we saw the third quarter moon, and as soon as I saw that third quarter moon, it looked as if they were coming in for a landing. I couldn't believe that the moon would look like that. And I thought, my God, I mean, inside of me it said, hey, my God, everybody's got to see this.
Oh, now here's a polished one.
These people start with a raw hunk of glass, and then even with the unsilvered mirror, they look at the moon and they can see all those craters. They're flabbergasted. That's what gets everybody.